this unit is focused on methods to find integrals. Now, derivatives are generally, you got the formulas, right? Product and power rule and those sorts of things. You have more than just the rules to follow. They're easier to do and easier to find. Antiderivatives, okay, so integrals, there's a lot of advanced techniques, more than we even will do in here, because it's just harder to find them. So there's ways that we had to come up with to find integrals. So we're going to look at those, a few of those, and I actually didn't have some, I didn't give you many applications last unit, so this unit got some applications at the end. And really, it's building to our last unit, which is full integral applications, which is really fun. Thank you. Okay, so we're looking at integration methods. How can we find different integrals? So let's go to the first page there, and today we're going to talk about slope fields. First thing we're going to remind you, a differential equation was an equation with a derivative in it. So it could have been, here, like sometimes I gave you a function like this, and minus x or something. And I said, I find f, little f, right? You just did the antiderivative. But this is a differential equation, so we've done this, x cubed over 3. This is a differential equation because it has a derivative in it. Something, when it's in that form, we can actually do something to form a nice general way to find an integral. Okay, so that's our review, first of all. Okay, that means it has a derivative in it. Let's do a problem. I want to do this one, this is a review one, but I want to do it just so that we can see what it's really finding. So this was an initial value problem from last unit. Find the particular solution to the equation y prime equals e to the x minus 6x squared, and it goes to the point 1, 0. So what we did is we would do an antiderivative to both sides, an integral to both sides. This one goes back to y. Derivative and antiderivative cancel out. Antiderivative over here is e to the x minus, and then I'm going to do power rule. So keep 3 over 3 when I add 1. And therefore the 6 over 3 becomes 2x cubed. Now I need a plus c because this was an indefinite interval. Alright, so what we can get with this is a general solution. That's what this is called. We don't know what c, but c could be really any value if we want the particular solution. But this is the general solution. So if they give you a point, then we can plug in an x and a y and find c. So I'm going to plug in 0 for y and 1 for x. I don't know why I didn't do that right. It's 1. So I put in 0 for y and 1 for x. And then we can just evaluate. So here I get e to the first power, which is just e, minus, this will be 2. 1 cubed is 1, so it's going to be 2. And so then I can subtract e and add 2. So to get c. I subtracted e and added 2.
Why isn't there a negative e?
A negative what?
Why isn't the e negative?
It is. There's a negative from there. So let me write my final, so what is it? This particular solution. E to the x minus 2x cubed, and then c is negative e plus 2. Alright, so the reason I want to do this example is to contrast. This, with c in it, is a general solution. This, with c solved for, is a particular solution. And what slope fields can do is get both, actually. It'll get us a generally all of the general solutions, but we can also focus in on one particular solution. So let me talk more about what a slope field is, and then we'll find some. Doing all right so far with that one? General, it's basically just general versus particular solution. All right, so this is a slope field right here. Let me show you what we based it on here. So this is starting with the differential equation y prime equals 2x, or you call it f prime equals 2x, or dy dx. Those all mean derivative. So the derivative equals 2x. Y prime, f prime, dy dx. Now we know that some of these we can't actually do, but some of them we can. Like this one, we know the antiderivative would be this, x squared plus c. Right, kind of like the one I did last. Then if we know an actual point it goes through, we could solve for c and get the exact solution. But what a slope field does, I mean, look with your eye. Can you see how it outlines all of the solutions? Every single one. So they said, what if it goes, they said, what if it goes through -1, -1? And wow, it's pretty hard to tell on your sheet, and even up here. This is -1. The scale here is a little crazy. That's -1, that's -2. It's just a little hard. That's 1, 2. Just a little hard to see. But they said, what if it goes through -1, -1? That point right there? Well, then we can get the actual general solution. I'm sorry, particular solution. And you see what they did? They just followed the slope field. So these are all the slopes, these little lines, these are the slopes of our differential equation. So right here they said, oh, the slope's going down, so they did that. And then we get here, it's curving a little more. Well, here now it's horizontal. And here it's curving up. And now here it's curving up more, and they followed it. And it outlines a parabola, which we knew that it was on this one. Okay. Now you say, well, what if we knew it was going through a different point? Well, you just trace it along. So like, what if we knew it was going through, this point right here? Well, that says you follow the slope up, and this one's slope curving straight, and then up this way. And it's a parabola again. So that's what a slope, also called a direction field. I'm just going to call it a slope field generally, but also call it a direction field. You start with a differential equation, so again, just has a derivative. And you can, I'm going to show you how to do these in a second, but it outlines all of the solutions. Okay. Even if we don't have a single point, -1, -1, even if we don't have this, it outlines all of them. So I kind of said all that. Let's see. Now, here's how we're going to find them. So let's say I'm starting with a different one now. The last one was 2x. I'm switching to x squared. Here's what we do. We just think of f prime equals x squared, or y prime equals x squared, dy dx equals x squared. That really means slope, right? Isn't the derivative representing slope? So in your mind, you really translate this to mean slope. Slope equals x squared. What you're going to do then is we just take some points. We just start throwing in some points. That's supposed to be quotations. Putting in quotes there. It's not really slope, right? But it represents the slope for that function x squared. And so we look at different points, and we can evaluate the slope at every single point we want, and create that slope field. Now I say here, before we do one, I say, well, I know some of you are like, well, we know this one, right? It's x cubed over 3 plus c, right? So this is what it's going to look like. That's true. That is what it's going to look like. But we're not always going to know what it looks like. Plus later, we're going to have something with x and y in it that we really wouldn't know what it looks like. So, all right, I basically sum up the rest there in that, yeah, I basically said it all there. I'm ready to go on the next page. Any general thoughts before we do some slope fields? So flip the page, and let's do, let's stick with, I want to stick with x squared. Yeah, I didn't bring it over here. So let's stick with x squared, and I'm going to show you what's happening here. I have this table. I don't know if I'm actually going to use it too much, but we're working with x squared on this. Okay, so our function is y prime equals x squared, or dy dx equals x squared. So it really means the slope equals x squared. So what we're going to do is we're going to plug in any point we want. Okay. So that's what I was doing over here. I was just throwing out some points. Well, let me start with 0, 0. So at 0, 0, I'm gonna plug that in where I can. All right. So this is at point 0, 0. Well, this one, and down here, well, some y's involved, but this one only has x. So I can't actually plug in a y value. I'm just plugging in 0 for x. And I would get 0 squared, which is 0. So what this tells me is I go to the point 0, 0, right here, and I make a slope of 0. And I'm not going to make a full line. I'm just going to do what a slope field is. It's just part of a line. Right? So we'll go back to the last one. So it's going to look like this. You're just going to make all these little lines. Q. Okay, so I'm going to the point 0, 0. Isn't a horizontal line slope of 0? So I make a horizontal line right there. So I don't connect it any further, just at 0, 0. Horizontal line. So this is why I say you can use freehand, or you can use your straight edge if you want. Now it's good to look for some patterns. Okay, you don't want to be plugging in 20, 25, 30 different points up here, right? There's almost always a pattern. So for example, what about the point 0, 1? Well, if I plug in, well, I can't plug in y, but I could plug in 0 for x. And at the point, it would be 0 squared, it'd be 0, right? If I plug in, it's just the same. So at 0, 1, it's also going to have a slope of 0. How about 0, 2? And 0, 3, and 0, 4, and anything with an x coordinate of 0, because there's no y value. So basically the pattern on this one is every column is the same. Every column is going to be the same. So let's go to 1. Let's go to, this is 1, 0. It doesn't matter, we choose 1. All of them vertically are the same. So we go to 1, 0. Now I plug in 1 for x, 1 squared is 1. So at the point 1, 0, my slope is slope 1. So here's where you say it's a diagonal line, right? So I'm at 1, 0. Here's where you could use your ruler. Isn't it a slope up 1, right 1? So you really take your ruler and connect it from here to here. Now, you're not drawing that red. You're just going to draw this line right there. So I'll take it back here. So it's hard to illustrate up here, but I'm really taking my ruler right there. Now, on a slope of 1, you can kind of eyeball it a little bit more, but I'm just going between these 2 points, up 1, right 1. I'm just making a slope of 1. See, I can't freehand it very well. I'm really taking my ruler and lining it up there so it has a slope of 1. Because we already said any column has the same. So, for example, just anything in this column will have that same slope. So on the next one at 1, 1, I'm lining up these 2 points. And just drawing in that line. So ruler. And you can, again, I'm freehanding it, but you can see what's happening there. Let me keep going with 2, 0, and again, we'll kind of generalize after that. But at 2, 0, we plug, there's no place to plug in y, but I can plug in 2 here, and it'll be 2 squared, which is 4. 2 squared, which is 4. So I go to the point 2, 0. I'll go green this time. So I go to point 2, 0 right there. I need a slope of 4. Which is 4 over 1, meaning up 4, right 1. So those 2 points. Back to that one, up 4, right 1. So with my ruler, I'm just lining that up and making a slope. Again, I'm gonna freehand it here. Basically, once you get to about 4 and above, it's approaching a vertical line. Right, you see, I mean, I didn't draw it perfectly, but it's almost a vertical line here. It's gonna be the same at all of these. So this is why I can kind of generalize it looks like that. And guys, if we went to the right anymore, it would be even more a vertical line. So this is where I just generally generalize. At 3, 0 would be 3 squared, which is 9. Slope of 9. Up 9, right 1. I mean, it is really from here up to like even more than that, right? It's really almost a vertical little slope line there. So I'm just making generally when they're this vertical, almost vertical, you can generalize like that. Okay, the left side. Let me just do that real quick. It's gonna take a second here. If I go to -1, 0. Then -1 squared, I can't plug in y, but -1 squared, when I plug in x, is -1 squared of 1. Slope of 1. That was the same as this one, 1, 0. So guys, this column is going to be the exact same as this column. As this red column right here. So like here, slope of 1, up 1, right 1, connecting those two. Not drawing in a full line. Okay, so again, I'm kind of freehanding here. It's the same as one. And you can imagine the next one is going to be the same as the green, because it's going to be -2, 0, -2 squared is 4, which is the same as the green over here. So I'm going to do the same green one. It's really a slope of up 4, right 1. So not quite vertical, but getting there. Okay. And by the way, you'll notice I didn't do that far right one. I'm kind of stopping here in this one. This one would be near vertical, and any ones to the left and right of where we're at are near vertical as well. Now this one we can go back and think about it. Don't we know x? Okay, it's x squared. We know that the antiderivative is x cubed over 3 plus c. Okay. So this has to look like x cubed. Do you see it there, how it does? Like if I picked a point here, it could go down, or if it says followed it up, I follow it here, now it's horizontal, now it's going back up. Oh, so this, what I drew in here, that's the particular solution. The slope field is all of the general solutions. So that's what's nice about slope fields. You can get all of the solutions at once in a graphical approach. That's kind of fun. I think I'm going to try and do 2 more below. I'm going to skip 1. And then I can answer on that one though. And I think that one I left too many. Yeah, I don't like to make a grid more than 4 by 4. Even maybe like 3 is enough. Right on that one. 3 units to the right. Okay. Well, let's try 2 more. So we're gonna make a slope field, direction field. I say if you want to make a table of values, I didn't even do that in the last one. I just did 1 and looked at a pattern. Let's do 2. So the derivative, in other words, I think of my slope, dy dx, x plus y. So here we can include y's. And this one, see, I don't know what that looks like, because it has x and y in there. So let's choose a point. I like to start at the origin. So 0, 0. So if I choose the point 0, 0, I have to plug in both 0 for x and 0 for y, and I get 0. So again, here's what I do. I go to the point 0, 0, and do a slope of 0. And we said anytime you have a slope of 0, it's a horizontal line. Horizontal line. Let's see. So instead of just choosing random numbers, here's what we should do. We should think about it. What other numbers, when we plug it in here, will give us a slope of 0? So you think of another
0, 1.
That wouldn't give us.
Oh wait, 1, 0.
Yeah, we needed, so when we plug it in here, it would get a 0. 2 and -2. right? Because it'd be 2 plus negative 2. Or
4, negative 4.
4, negative 4. Or 1, negative 1. Right,
3,
we'll plug
negative 3.
3, negative 3. So that's what I'm saying. Look for a pattern. So now let's go. The first one's a 2, negative 2. Right here, slope of 0. 3, negative 3. Slope of 0. 4, negative 4. You see how it's going to be diagonal is the pattern this time. 1, negative 1.
Wait, how do you know to draw it like this way about it?
A line. We're doing lines with a slope of 0. Slope of 0 is horizontal. Yeah. Yeah. So what's next? Negative 1 and 1. And negative 2 and 2, and negative 3 and 3. Oh, that one got a little off. Okay. So again, it's much easier to look for patterns instead of choosing random numbers. You'd have to fill in a lot of random numbers. So this one, the pattern, all diagonal can be the same. Let's do another one. So how about, you want to go with like 1, 0 or 0, 1? Let's do 1, 0. There. So if I plug in 1, 0, it's 1 plus 0. That'd be a slope of 1. So I go to the point 1, 0. I do a slope of 1. So again, I should outline it with my line. I'm really doing a line, right? Up 1, right 1. So technically I should line it up with my ruler. What other numbers can we plug in that would give us a slope of 1? 2, negative 1, that'd be 1. 3, negative 2. Okay. 4, negative 3. So 2, negative 1, a slope of 1. At 3, negative 2, slope of 1. And again, you'll see it's the diagonal here. So another one here would be 0, 1, slope of 1. Negative 1, 2, slope of 1. Let's do 2, 0. 2, 0. Right there. That would be 2 plus 0, which is 2. So now, right here, 2, 0, I'm really doing up 2, right 1. So I'm doing that slope. Right, but I take it back here. So basically on this one, it should be not vertical yet, but it should be a little bit more steep, that slope. That's not my best work there. Oh, that one's better. You can see it's a little more steep than the last one. Okay, and then I'm just going to look for others with the same 3, 3, negative 1. Again, I already mentioned it's diagonal. I mean, at this point, you could just diagonally just do all of the same. 3, negative 1, 4, negative 2. So 3, negative 1. Basically, all along here, I'm doing the slope up to that point, but they should all be the same diagonally here. Okay, and at this point, you might be able to see as we continue to go right here along the x-axis, it's just going up with a slope value of 1. So right here, the slope was 0, slope 1, slope 2, slope 3, slope 4. So let's do one more here. This one right here, it should be up a slope of 3. I'm going to slant it even more upwards here. Oh, okay. And I'm going diagonal now. 3. That was pretty good. You can see it's trending more up there. After this, guys, here's what I do. I mean, slopes of 4 and on are almost vertical. So all of these are getting more and more steep, and I fill them in more or less vertical along here. I'm going to go back and do -1 right here, -1, 0. I'll do a few of these. let's see if we can just do one more after this. So, I'm going to go back to negative 1, 0. So, negative 1 plus 0 is negative 1. So I need a slope. So I'm at negative 1, 0. So negative 1 is down 1, right 1. So it's along here. And again, diagonal is all the same. So like 0, negative 1, that point would also have a slope of negative 1. This one's kind of nice. It's all these. It's basically a line but broken up. See this line along here? That one's kind of cool. It's almost an asymptote here. Just it breaks up the graph. You'll see in a second. Yeah, let's do one more, maybe two. Let's think of one more. Negative 2, 0 would be negative 2 plus 0, which is the slope of negative 2. So negative 2, 0 here would be a slope really about down 2, right 1. So right there. It should be, yeah, that wasn't bad. It should be, yep. And diagonally all along here, I'm doing the same slope. If you're not sure, you can always plug values in just to check. God, that's pretty good.
He missed one down there.
Thank you. I'm going to generalize after this because the rest is there are slope of 3, 2, 1, or sorry, 4, 3, 2, 1, slope of 0, slope of negative 1, negative 2, negative 3. So now it's just going down even faster here. All right. Now this one, let me just talk about the particular solutions. I know I can finish all of it, but particular solution. There's actually 3 cases here. If your point was on this, if it was like here, the particular solution would just be that line. I kind of missed there. It would just be this line. If your point was over here, so like here, it would follow this up. It would follow this curving down, curving horizontal, and then going along the asymptote like that. And if your point was over here, it would just follow this up here and just follow this down. And it's not really doing much. It's just kind of trending down there. That's it. So, any thoughts on that one? I want to show you too. I gave you on there. I think it's at the bottom. Yeah, at the bottom of that page. You can check these. So there's not. I don't have an answer key for these, but you can go to this slope field plotter. Here, this is there. This is actually X plus Y, and you can see it'll give you. I can take that off. There's the slope field. Same one we just did. But you can also throw in one of those particular solutions, so you can see what it would look like. So if it goes through certain points. Good stuff. We finished with one more. Any thoughts on this? Okay, last one. X divided by y. X divided by y. All right, I start with 0, 0. So at the point 0, 0, it would be 0 divided by 0, which is what? Undefined. Which is a slope of what? What does it look like?
Up.
Undefined slopes are asymptotes, basically, vertical line. Yeah. So right here, at 0, 0, it's a vertical line. What other points, what other points would have a vertical line? It's just, we need the y value basically to be 0. Right? Something divided by 0. So 1, 0, 2, 0, 3, 0. Right? They're all going to be something divided by 0, which is an undefined slope. So 0, 0, 1, 0, 2, 0, 3, 0. They're all going to be vertical lines. Like that. again, look for patterns. Let's do 0, 1. So 0, 1 right there would be 0 divided by 1, which is 0. Slope of 0. So horizontal. I missed that. 0, 2. 0 divided by 2. Slope of 0. 0 divided by 3. 0 divided by 4. 0 divided by -1. 0 divided by -2. All of these are going to have a slope of 0. That's nice. X-axis is vertical lines. Y-axis, well, y-axis is horizontal line. Okay, now we got to throw in some other values. So I go quadrant 1. I go 1, 1. I go 1, 1 right there. That would be 1 divided by 1.
1. Very good.
2, 2. There, yeah, you just got to think of patterns. So 1, 1 is a slope of 1. Up 1, right 1, diagonal line. We already said it. 2, 2 would be 2 divided by 2. 3, 3. 4, 4. So actually, and also -1, -1 down here. So this is a diagonal line. The line y equals x. This one's pretty too. I love this one. It's broken up into like these 4. I don't know. It's great. So then you might. All right, there's diagonal line there. Probably the same over here though. Like 1, -1. Right here. 1 divided by -1 is -1. That's a slope of -1. Down like that. 2, -2. Same. 3, -3. All of these diagonal. -1, 1, -2, 2. Isn't that fun looking?
Looks like a spider.
It looks, yeah, I don't know. It does. Wow. Let's fill in, let's probably fill in, because all 4 of the quadrants, quadrant 1, 2, 3, and 4, are basically the same. Just kind of reflections of each other. Let's just do quadrant 1.
2, 1.
2, 1 would be 2 divided by 1, which is 2. So I need a slope up 2, right 1. I'm going between these 2 points. After that, it'd be like 4, 2. Right? 4, 2 would be 2. So 2. 4, 2. So now, see, this one, the pattern jumps a little bit. It's like right 2 up 1, right 2 up 1. And down here, it's going to be kind of a reflection. I'm running out of time. Well, I got a few minutes still. If I do 3, 1. I do that every time. 3, 1 right here would be 3 divided by 1. So it would be a slope of 3. 4, 1 would be a slope almost vertical now, of 4. 3, 2 would be, right here would be a slope of 3 over 2, 1.5. So you got to go up 1.5 over 1 and be looking right here. And basically, I'm running out of time. It makes this little, almost like parabola-like here. Alright. I didn't do that perfectly, but it kind of makes, almost like if you had a point over here, it'd be like this. And that's what all of these, I guess it wasn't pure quadrants, but it's like all of these make this. That's what this little field looks like. So, looks like I'm gonna pretty much stop there.